we started talking about how do you write an exponential function given 2 points like this, and we were going to do one on our own, but we kind of got caught in the transition of classes, so I think we should do another one together. Are you okay with that? You guys okay with that? Okay, let me pick 2 points right here. How about we pick the point 1 comma, I have to think, 18. And then let's let the other point be 3 comma 162. Okay. Take a look at your directions on the left again. What are we supposed to do?
Take 2 divided by 1. So like the second point that we get over the first.
Want to write an exponential function of the form what, kids?
Y equals AB squared.
AB to the x.
X squared.
Yep. Okay. You know, yesterday I said start with the second point up top first and put the first point on the bottom, didn't I? I think I want to change that a little bit. Here's what I want to tell you for a rule, I think. Instead of putting the second point over the first, and it's going to work out that way most times because of the way they list this, but look at your x values here first, all right? You want the point with the bigger x value to be up top. So, and maybe I should write it like this. Maybe big X over what? Big X over little x. Okay? So here we go. Again, we're taking on this form y is equal to what here, kids? Okay. So am I going to plug in 118 up top or 3 comma 162 up top? Okay. So what would take the place of y given this point right up here? How much? 162. So we're going to say for the big X values, we're going to say 162. That's going to equal some coefficient of a, or some initial value of a, times my base b to the x power. Well, what's the x power here, kids? 3. Okay. Then on the bottom here, what are we going to write at the bottom? Equals ab to the what? Now guys, we talked about this yesterday. If 162 is equal to this mess, and 18 is equal to this second mess, then 162 divided by 18 should be the same as this mess divided by this mess. So somebody quickly, 162 divide 18, what do we get there?
9.
So we have 9 equals, what do the a's do to each other here, kids? And then how about b to the third over b to the first? B to the, okay, what's that make b here, kids?
3.
Okay, so when they say write an exponential right here, guys, your job right here, you're trying to solve for a and b. Okay, well we know b now, so it might be a good idea to use b to solve for a. So here's what I'm going to write down here. Once I know what b is 3, I'm going to come back to my exponential form, y equals ab to the x. So I'm going to start out y equals a times b, but what's your b value, kids?
3.
And then once you get to this point, you can choose one of your points to plug in for x and y. So you want to use 1 comma 18 or 3 comma 162 to plug in now?
118.
118 might be better to work with. So from this right here, if I choose the point of 1 comma 18 to put in, what are you going to plug in for y? 18 equals the a value we're trying to solve for times 3 to what power? Well, what is 3 to the first, kids? So this is really 18 equals 3a, doesn't it? Doesn't that make that 18? Yeah, that's a 9 right there. I'm sorry. That's the number 9. I don't know what it is now. Looks pretty bad, but you get it, right? Kids, isn't this 3a on the right? If 3a is equal to 18, what's that force the a value be?
6.
if our job rate, if our job rate here is to find out what A and B are, have I found out what my A value is? Have I found my B value? So in the end, we're going to say y equals, what's the A value you're plugging in? 6. The initial value we're starting with is 6. The base is going to be, here's your function right there, y equals 6 times 3 to the x. And think about it, kids. Look at the point 3 comma 162. Anybody have a calculator handy for me? Go 3 to the 3rd power. What's 3 to the 3rd power?
27.
27. Now take that times that value out in front of 6. $162. What did we want to get out of this here, kids? What value did you want to get out? Okay. So, first thing you're going to do, plug in your x's and y's in this form. Use the big X value up top, little x value on the bottom. Use that to solve for which variable first? B. Once you know B, plug it in down here, and then use another point for x and y to help you solve for A. Once you know your A and B value, plug them in. That's your exponential that models that right there. Okay? All right, so here's what I kind of like. We're going to be able to use some technology to do some things. Finding an exponential model. Okay? It says a store sells what? Basketball hoops. The table shows the number y of hoops sold during the X year. Write a function that models the data. What's the note say up top? Finding and what? If it's exponential, then the common ratio should be pretty much the same. So here's what I'm going to tell you, kids. Exponential models are going to be formed when you have what's known as a common ratio. And that common ratio typically becomes your base. Okay? So help me, kids. Let's find that common ratio. What's 31 divided by 17 for me, kids? Let's go 2 places, maybe. 1.82. Somebody take 50 and divide it by 31 for me. 1.61. Do 85 divided by 50. Are we getting the exact same values, kids? No. But are they pretty close? 1.8, 1.6, 1.7. They are, aren't they? Okay. So when I ask you to write what kind of a model here, kids? Exponential model, we're looking for a common ratio. We're finding out when we divide all these, they're not exactly the same, but they're pretty gosh darn close. I think we got 1.8, 1.6, 1.7, didn't we? Okay, here's what I tell kids typically to do. If you don't get a common ratio and they still want you to write an exponential model, I'm going to say, well, isn't the exponential form of an equation y equals a times b to the x power, kids? Would you agree with that? That's the formula for an exponential function. So here's what I tell kids to do. Okay, I like to pick the points on the ends. We're going to pick this point, and we're going to pick this point if we have to make an exponential model. So which point is my big X, kids? So we're going to start this out as big X right here. I'm going to call this big X. And I'm going to call this, anybody want to say it for me? Little x. Oh, let's get some goofy colors today. How about that? Yes. And a little bit of this. Big X, help me fill it in. What's going in for y? 498 equals a times b to what power, kids? Okay, let's do the little one. My little one, what's going in for y, kids? AB to the what? Ooh boy. Let's divide, kids. Somebody want to run 498 and divide 17 for me? 29.29. Say one more time. 29.29. 29.29. All right. So I've got 29.29. That's going to equal what, kids? B to the 7th over B to the 1st. The A's are going to cancel, so B to the 7th over B to the 1st would be... So what root are you going to have to take of 29.29 to get our base? Take the 6th root in your calculator of 29.29 and tell me we're somewhere around that 1.6 or 1.7 or 1.8. 1.7? Should we call it 1.76 today since it rounds that way? Are you guys okay with that? Yep. And wasn't that value pretty close to what we saw with common ratios? The first one was like 1.8 something, the other one was like 1.66, the other was 1.71. So should we go 1.76? You guys okay with that? Everybody understand where the 1.76 is coming from? It's the 6th root of... All right, so B is from this, by the 6th root of this. What do we agree upon, kiddos?
1.76.
Okay, so let's use this information now that B is 1.76. I'm going to divide up here, and I'm going to say, okay, kids, well, hey, we can now say y equals a times 1.76. Who's calling? Who is?
I don't know.
Okay. Help me out, kids. I need help. Let's put the little point in. Is that okay to find the a value now? Okay. Let's go. What's going in for y? 17 is going to equal a times 1.76 to which power? Well, what is 1.76 to the first? Okay, so what I need to do is have somebody take 17 and divide it by 1.76 for me. 9.66. Okay, so a value is 9.66. My pen is falling apart, kids. I'm ready for a new Mimeo. I want the one that's a touch screen. You just use your finger for everything. All right, help me. What's my final model going to look like for this then? Y equals my a value of 9.66 times what? There it is. Okay. So kids, if I plugged 5 in, for my model, we better get an answer pretty darn close to what? If I would plug 5 into my model, I better get an answer out pretty close to... Okay, who has a calculator handy for me? Well, you know what? I'll do it up here. I've got it. I'm going to do 1.76 to which power first, kids? 5th. So I'm going to go 1.76, raise it to the 5th, and then times it by what now? And we hope we're pretty close to what? Are we kind of in the ballpark with 163? I'd say we're close, okay? Is this a perfect model? Is this an exact model? Or is this an approximate model? It's an approximate model, okay? We chose 2 points. That's the model it gave us. Now, I'm going to cheat on this a little bit. I'm not even going to do example 4, okay? Is that okay? I'm not even going to do example 4 because well, actually I will do example 4, but we're going to cheat on it. Is it okay with you guys?
Yeah.
Okay, here's what we're going to do. Example 4. You're going to love this today. Put decimals by this, okay? I wish I could teach a class just called decimals and show you all the things that are capable of doing with it. Wouldn't that be cool? You would take it? No? You guys have no idea how powerful that calculator is. Like decimals is like, I don't know. What's probably the best thing that ever happened in America? NASCAR, yeah. Decimals would be right up there for NASCAR with me, okay? By the way, Daytona 500 is only 11 days away. If anyone's worried about it. The real Super Bowl is in 11 days. Okay? Let's do this. I need some help, kids. Who's willing to take the natural log of 17 for me? We'll put those values. I need someone to do 31. Natural log of 31. Ellie, you got 31. Who's got 50? Natural log of 50 for me. P, who's got natural log of 85? Thank you, Maddie. Who's got natural log of 156? Carly, natural log of 274 for me. Who's on that? Jazzy, and I need someone to do natural log 498 for me. Who was my 17? We'll go 2 places. 2.83. 2.83. Next one.
3.43.
Next one was the natural log of 50.
3.91.
Next one.
4.44.
Next one.
5.04.
Next one.
5.61.
And then finally, natural log of 498. Who had that? 6.21? Okay, get those values in there. Okay, I'll move out of the way. You write those values in there first, all right? Okay, first thing it says to do is what, kids? Create a scatter plot. So I'm going to jump into decimals over here and create this scatter plot for us. You guys, you have the points written down? Because you're going to need to read them to me. Okay, watch this. This is so cool. All right, in decimals, let me clear everything. Clear that. Take this home.
Tomorrow it's going down. You're in dark in self-defense class. You're self-defense for a reason. Yeah, you're not good at it.
Oh, it's because he's like this. I know what I'm doing. Oh, the backhand. Yeah.
Okay. That's not self-defense. That's literally just No.
All right, you ready, kids?
No.
You guys remember how to create a scatter plot with a table, right? So click on table. 1 comma what, kids? How much? 2.83. What was the 2 value? 3.43. How about the next one? 3.91. 4 was what?
4.44.
Do I have that right? 4.44? What was 5?
5.04.
And 6.
5.61.
All right. Got a scatter plot. Almost looks linear in nature, doesn't it? But, oh, is there? I'm sorry. What's the next one?
6.21.
All right, no problem. Looks kind of linear, doesn't it? But it says to write what kind of a model for this, kids? Exponential model. So we've got to write a model here of the form. We've got to write a model of the form
form needs to be y equals a times b to the x. And you know what? We can go through all of this again up here. Put these numbers in, choose two numbers, do big X, little x, plug them in, find b, use b to find a after I plug in x and y. Or we could try to see if this little guy here can help us out. What do you want to do? You want to go through all the work again, like we have done, and like we know how to do, or do you want to see a shortcut? Okay, check this out. You guys remember when we were doing some linear regression and we would put in like y1 or quadratic regression y1, and then that little squiggle is about ax1 squared plus bx1 plus c? Well, guess what we're going to do here? If we use decimals, we're going to say y1 squiggle. That's the worst looking squiggle I've ever seen in my life. Got better? Should we try it? See what happens? Okay, so if you're asked to use technology to come up with a model or an approximation, you have to understand which model we're using, okay? This case, ab to the x is my general form for an exponential function, so I have to come into decimals and I need to say, hey, I have these points plugged in. Now notice up here, kids, we're using y1 and what else? Okay, check this out. I get excited about stuff like this. You're going to type in y1 like this, and then you're going to put your little squiggle, and it's approximately a, b. How do I raise this to a power, kids? Here you are. And type in x1. Holy smokes! Does that look like an exponential function? It's like my airplane taking off. Does it look like it hits most of those points or pretty gosh darn close to those points? Remember we talked about R values. If R values are pretty close to 1, this is a good model. Look at my R value right here. Point what? Holy cow, that's a good approximation. We said that when you're writing exponential functions, you need to plug in for what values? A and what? B. Gosh, it would be nice if I knew what A and B, so say parson. And I'm like, what? You're like, move that stuff at the bottom, so say it. Move that stuff. Oh my gosh, what do they give you down there? What do they give you down there?
And then they cry.
Oh. What's my model going to be for this? Let's go 2 places. Y equals 2.66 times 1.13 to the x power. You likey or no likey? Likey? Good way to check some of the work you're going to do, right? Okay, so let's type that in. You guys tell me, what was that? What did we get from the model? Oh, shog diddy diddy, the cat and the kitty, move. There we go. What do you get from this, kids? Y was 2.66 was my initial value. My base or my rate of growth was 1.13 to the x power. Oh my gosh, that is so cool. Sorry guys, I get a little excited about stuff like that. Does that make me weird?
Can you stop?
Make me weird? So I have an idea. When you type stuff in, can you just put y in there? Or do you have to put y1? And can you put equals in there?
No.
You're going to put that squiggle in there. So we're trying to make an approximate model for all fitting this data. And when we see R values pretty gosh darn close to what value here? 1. In this case, 0.9918. You know you're pretty darn close. Okay? So let's go on to the last page of notes and see what the heck is there. Everybody have what they need from this first of all? Let's roll, kiddos. Example 5, finding an exponential model using what? Okay, it says use a graphing calculator to find an exponential model for the data in extra example what? Okay, I'm going to go back to my example 3. Example 3 is this number right here. Do we already have an approximation here, kids? We said y was what here? 9 point what? Times to the x. Okay, now I'm not going to get too worried about that. We've already done the extra example 3, so here's what I would like you guys to do to make sure you're good. You're going to help me with this data. We're going to put this in. Okay, so we're going to use the data from example 3. So the data from example 3 using, using Desmos. And the idea that y1 is approximately ab to the x1. Let's plug that data in for example 3, because we've already plugged it in for example 4, right? We already did that on the previous page. We already did that on the previous page. So you guys are going to help me plug in the data from example 1, all right? I'm sorry, example 3 I meant. Okay. So that first point was 1 comma, was it 17? All right, so let me clean this up. All right, kids, I'm ready. 1, 17, what was 2? 31? 3 was 50, that's all I remember from there. What was 4? 80?
No.
5? What was 5?
156.
156. What was 6?
274.
274?
Yes.
And 7.
498.
Okay, so I'm going to zoom out so I can see my points a little bit. Okay, there's all my points. We need to make an exponential model for this. I'm going to change the x's a little bit so I can see this a little better. Hey, what happened?
Stop.
Okay, I changed my window a little bit to make this fit. Okay, what am I going to type in to get an approximation, kids? Y1. Squiggle. Do I have a curve? It would sure be nice to know the A and B values. We had what for an A value? 9 point. What are they using? Okay, so kind of close. It depends on what points you chose, but this is going to be more accurate because they're considering all points. How about the B value? What do they come up with? What do we have for a B value? So were we pretty close? Yeah, based on 2 points, we were pretty close. But this one's not considering 2 points. It's considering all points. So who's probably going to be more accurate? They are, but we kind of have the idea or the principle for this. Okay? So by Desmos, you may not get exactly the same thing, but understand the work that you do has got to be pretty close to this. So by this, I get 8.43 times 1.79. So we'll write that down. And it's not a big deal. If there's a little bit of variance in it, that's okay. So what did they get again? Y was approximately, what was the A value there? 8.43? Times 1.79 to the x. My question is, how do they compare to what we got? Exact? Close? Or not even in fair play? We were on the infield. We're playing ball with them then. I like it. We're competing. That's what we do. Okay? So we were close. All right, let's talk. Last example here, and then I want to get a short, quick quiz out to you here today. Do you guys understand what I want you to do? Do you guys understand what I want you to do and how Desmos works? Okay, good. The height of a tree increases with its age. So as it gets older, what happens to the height? At the time of planting the tree was 1 year old. Okay, the table shows the height, h, in feet of the tree at a specific age t. It says use a graphing calculator to find a logarithmic model of the form what, kids? H equals b times what, kids? Natural log of t. Now you need to understand something. Are there any x's and y's in here anymore? When we put stuff in decimals or when we use technology, everything is based on which variables? X and Y. So X is like an input, Y is like an output. So this age T is kind of like my what, kids? And this height is like my Y. Okay? I'm not typing in. Somebody get into decimals and tell me what to type in for your table. Actually, you guys type your points into decimals. You do that. Get into decimals and put in your table. Okay, so decimals, step 1. Oh, I like what I'm about to put. Use decimals. We're going to be really formal today. How many of you guys are in family consumer science? SCS. Set the table. I want steak and lobster. And I don't care after that. Steak and lobster. Okay, Sam? Okay, then I guess I'm not getting steak and lobster.
It's a family consumer science I was in.
That's not the one you were in?
I was in the baby class.
I would love to teach culinary class. How many would take culinary class if I taught that?
Yeah.
Learn how to cook like fine foods. Fine. Who would do it with me?
I would.
Maybe I'd make win time fine culinary cooking from now on. What should we cook up
make it.
tomorrow?
Wait.
Salmon.
Let's do salmon, because I was kind of thinking the same thing. I know it.
Table.
Should we braise it with something? How about braise it with a raspberry plum sauce?
Yeah.
Raspberry plum wine sauce. Oh my God. Are you in, Sam?
No.
I'm going to get the big hat that goes way up here. Probably hit the ceiling. You don't like salmon? Oh, I love salmon.
It's so good. It's the best.
I've never had
fish
I tell you, one place I love to get the salmon is at Tokyo. Do you guys ever get the salmon at Tokyo?
Yes.
It's so good. All right, do you guys have, who set the table in decimals for me?
Yes.
Now, who's got a table in there at least of points? Okay, now, this one here you have to be very careful on when you put your approximation. Step 2, do your approximation. What's the model say that they want us to do, kids? They want us to do H is equal to what? A plus B natural log of. Now understand this, again, we're looking for parameters A and B. You need to understand, again, H is like the X, I'm sorry, T is like the X and H is like the Y. So your step 2 for my approximation, you're going to type in Y1 is approximately A plus B ln of what? Here's what you need to type in. Make sure you're typing Y1. And make sure you're typing X1. I'm curious, how many people have put this in their computer right now? 1, 2. Let's make sure we agree. When you get your A and B value, what's it say your A value is? 5.31. And how about a B value? What are you getting for B? 7.82. So I'm going to say right here, and I'm going to put this back in terms of H and T. I'm going to say, in this case then, H of T, which is like the Y, is equal to, I'm sorry guys, I forgot. I think you said A was 5.31. Plus, I forgot the B value. 8. 2. Natural log of, and then X1 is like my what, kids? T. So now, kids, it says estimate the height of the tree when it's how many years old? 3 years old. Okay, so here's what you need to do, kiddos. You need to take and put 3 in for what here, kids? Okay, now at age 1, what was the height? And at age 4, what was the height? So we hope, if we've done this correctly, my answer should be between 5.5 and 15.5. That's reasonable, right? Okay, somebody go natural log of how many years for me? 3. Natural log of 3. Take that answer times 7.82. And then add in what?
Add in 5.31. What do you guys get for a 3-year-old tree? I'm sorry, I didn't catch that. 13.9. And how was height measured? Was it measured in feet? Yes. Do you guys understand or recall how to type stuff in to set the table, first of all, in decimals? Understand how to set the table? And then in the next step, do you understand how to put your approximation for the specific function they want for you? All good with that? Okay. I have a short quick quiz I'd like you to get started on. I sent out a new online page for this. Tomorrow's going to be a work day if we're here. I'm very worried about losing the day tomorrow. If you don't get it done today, just bring it and you'll have it tomorrow to work on. I think if you go quickly, you might have enough time. It's going to be tough though. So get started on it. Did I get you one of those? Okay.
Not for the